I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. We are here with Intel as part of their launch of the third generation Xeon Scalable processors on April 7th, 2021. One of the signature elements of Intel's Xeon Scalable processors are their security capabilities. Certainly, they have instructions to help accelerate things like IPsec and other security calculations, but the latest CPUs have something called SGX that allows us to secure workloads even on untrusted platforms. This, I think, is something that is really interesting, but also maybe a little bit confusing for people. So I wonder to start out with, Scott, can you maybe just tell us in your words, we're a CIO. What is SGX and how does it benefit me?
Well, software guard extensions is technology that has been around a long time on the client platforms. This is now finally making it into the data center. And what it allows an ISV to do is to shrink the attack surface of an application to the smallest possible. It uses encrypted memory for the small pieces of code and data that you need to keep most secure. And it's only visible to the application that creates this small, what we call an enclave in the memory. Therefore, you don't have to trust the rest of the software stack. You don't have to trust the OS, the kernel, VMM if you're running on top of a host VM, or even the BIOS or other CPU modes, such as the old SMM mode in the system. It's totally secured from attack from the software world, basically. We also, for example, have a way for you to attest your code that's running in an SGX enclave remotely. So you can be assured that, number one, that the code that's running there is your code. It's the code you're expecting. It's the latest version. But also you can go farther and you can get information about the platform and attest that the platform itself is completely up to date as far as the SGX TCB or trusted compute base is concerned. So you can see that the microcode is running the latest version, that the other authenticated code modules running in the system are all up to date, as well as all the other components that go into the SGX TCB. And again, this allows you to securely, once you've done this remote attestation, it can allow you to securely provision data into that enclave from a remote location. Even if you don't own the platform, you can be assured that it's secured.
So is this primarily for customers in the cloud, or is it for customers anywhere? I mean, is this attractive regardless of where the hardware lives?
Yes, it doesn't matter where the hardware is. It can be on enterprise, in a CSP. You can use it, as I said, there are many use cases for it. For example, AI machine learning is one good one these days, where people want to share data. They could train AI models better if they could share it, but they're not allowed to, such as the different PII, personally identifiable information that's out there. But now they can share this information, get better results from a bigger data set and pull out better statistics, basically. So that's one use case where you have different organizations coming together and sharing their data, as well as you as a company. You could do things like remote key services. So you could have HSM-like functionality all across the globe if you needed to, for redundancy or whatever your reasons of speed of access, et cetera. So there are many use cases, and it could be both, on-prem or in the cloud, depending on the use case.
So do you have to have SGX on both sides when you share data, or is SGX just needed on the receiving end?
No, you don't. You do not have to have it on both ends. That's really up to the ISV, up to your use case. We do have people who the end where you own the data, it doesn't necessarily have to have SGX, and they'll send it to remote sites that you want to make sure it's secured on that end. Like I said, you might not even own the platform that it's going to. That's where you need the SGX. But we have use cases using both. We have enclave to enclave attestation, or you can do remote attestation between two enclaves if you want to, but no, you do not have to have it on both ends.
Okay. Then a follow-up question: what happens when SGX realizes that, or the system is compromised, or that you don't have the latest version? How do you recover, or how does the user deal with such a situation?
That's a great question. We have what we call TCP recoveries to do what you just mentioned. Basically, if there's a vulnerability found, for example, and we release a microcode patch that fixes that vulnerability, it'll bump the security version number of that microcode in the SGX TCP. Before you dole out your secrets to that platform, you because of the attestation process, you set your own policies. You can decide if you're going to trust it or not. It maybe it's one version old, but you know why it's one version old. You're still okay to trust it. In that particular instance, you can provision your secrets if you want to. But if you see that at least even one thing is out of date, you can decide not to trust it, not send your data down there, basically.
Okay, thank you.
So my question is kind of related. I'm assuming that the application, the code must be written taking SGX into account. So you are providing some SDK or something, right? To enable developers to write applications that are SGX aware. But what happens if, for some reason, this application have to resort to processors that don't come with these capabilities? Is that something that can work on? I mean, regardless of, the application can work without the SGX extension on processors that don't have it. I mean, of course, not taking advantage of that.
Right. No, you would have to architect your application in such a way that it would detect SGX at runtime and use it or not use it. That's not an automatic thing, no.
Okay. So it's an additional feature that you would inject into your application to make sure that if SGX is available, the application can make use of it.
That's correct.
Thank you.
Correct.
I have two questions, Scott. So one is, how does this play out when you have a hybrid scenario of both on-prem as well as cloud-based resources? How do you leverage SGX? And then my second question is, what are kind of some of the swim lanes that you're seeing applications that are actually using SGX today, as opposed to the theoretical, what could use it, or what would be good use cases of it?
Yeah, so again, the hybrid question, it really depends on the use case as to how you use SGX in that case. So I can't give you a definitive answer there. But some going to your next part, the use cases that we are seeing the most traction in, for example, are healthcare. As I was already talking about, there's a program in Germany, for example, given out by their health, the government healthcare mandates, Gematic is the name of it, have, for example, dictated that all their records, all the healthcare records in the country have to be strictly electronic and have strict security requirements. SGX fit the bill for that. So that's one use case, for example. We have, I was talking about the AI/ML, there are some other use cases where people are sharing data, the records, hospital records of patients, and pulling all that, aggregating all that data and running, machine learning on that data to get better results. That's another one. Another example is in the financial world. We have banks that are doing the same thing, pulling their banking information together, and credit card companies pulling their banking information together into enclaves, running analysis on it, and detecting fraud. That's another good example.
And each of these are available in cloud only on Azure today, or has that changed?
For the Xeon E3s, no, there are a number of other CSPs that that have it, including IBM Cloud as an example.
What about Amazon and Google?
Currently, Amazon does not have it but I think neither Amazon nor Google, to my knowledge, have it right now, basically.
Okay.
SGX is available also to virtual machines, correct? It doesn't have to be used by application running on bare metal. It can be passed through the hypervisor and the virtualization layer, correct?
It can be, yes, but it has to have the support to do that, of course.
In terms of code running into the VMs, of course.
Yeah, passing through the feature, yeah, exactly.
Okay, thanks. But it's exposed to the virtual CPU.
Yes, exactly how it would be exposed, correct.
Thanks.
Yeah, I'm wondering if SGX cannot be used for compliancy, where it can detect credit cards and social security numbers in incoming data where you don't expect that data to be part of that data set.
Yes, it could be. That could be one use case, definitely. Mm-hmm.
Yeah, because that's the biggest thing is there's so much data being exchanged, and you brought up healthcare. My experience with healthcare is that there's a lot of they're trying to remove people's names and addresses and all that stuff. So it would be interesting that when data is being exchanged and there happens still to be some data in there, that it could be flagged before it goes further in the system.
That's correct.
Yeah. I was just on a call yesterday with a group talking about that very issue. When I think about using SGX, and I know this has come up in conversations in the past, but when I employ SGX to actually take action, there must be an overhead that comes with that, kind of a performance penalty if you look at it in a negative sense. What generally is that? If I'm trying to size or trying to kind of wrap my head around, okay, here's some guidance in terms of what that penalty is or how much additional resources I need to put to it, what would that look like?
Yeah, so that's a good question, but it's tricky. So when you're working with SGX and you write your application, like any application, you can have a poorly written one or a good one. And for SGX, when you're entering SGX mode, number one, the memory is encrypted, so there is a small performance penalty on that. When the data, anytime it enters or exits the processor, it's automatically encrypted, decrypted by the hardware, the memory controllers. So that's a small performance penalty there. But then when you start talking about application and creating your application, for example, if you have an app that enters enclave mode, it's like sort of a mode switch in the processor, and you start executing inside the processor, one thing to note is your full speed. Once your data's cached, your code's cached, and you're actually inside the enclave, it's the same as if it was an untrusted application, a non-SGX application. But if you write an application that jumps into your enclave, works on a little bit of data, and jumps out quite frequently, it's going to be a bigger performance hit in that regard, in that way, instead of if you jump in, work on a lot of data, and then jump out later on. So it just depends on how the app is written as to how much performance penalty you hit. And we don't really publish numbers on that kind of thing for the obvious reasons I just spoke about.
Yeah, what would be really nice is to put SGX on a smart NIC, before you actually enter, any other hardware components or even touch software. I think that would be a nice use case. I'm not sure if that's something you guys are looking at.
I think the challenge there, Frederic, is that you're trying to create that secure enclave all the way to the processor. Right. So what if you don't trust the system itself? You don't know, especially in cloud, we don't know how that's put together. It could be a white box system, custom configuration. It happens to have Intel silicon running as the CPU, but what about the chipsets around it? If you do it at the NIC, then you don't know what's in the middle or what's in that system.
Yeah.
Further to that, I have questions around trusting that memory. As far as the enclave goes, when I think of an enclave, I think of totally separate areas, even when coming to networking. But as far as memory goes, is it totally separate areas and no other process can write into that area if it didn't start that SGX enclave? Or is it simply encryption that because they don't have the encryption key, they can't get at that enclave? It's more specifically if an attacker was on box, do they have access to all the memory and it's just different encryption keys that protect the enclaves?
Yeah, so the enclave memory, it is just, there's nothing special about it. It's basically stolen at boot time, number one. It's protected by some range registers, like other types of memory in the system. And once those range registers set and locked, that memory is stolen away from the regular host memory until a reboot, until it's changed. And it's totally, that memory, that's the part, the range registers, that's the part that the memory controller uses to determine which range is set aside for SGX and an encryption done for that range. Yeah.
And that whole range is encrypted as soon as it's created, rather
That is correct. Yep, that is correct.
So allocation of physical memory to the enclave is not dynamic. It has to be set.
Yeah, the amount of memory that's set aside is the BIOS thing. So it's set aside at boot during BIOS and locked. Right.
Okay, to go back to my previous questions about virtual machines, let's say that we assign, I don't know, half a tera of physical memory to the enclave. Can this be shared across multiple virtual machines if they're running in the hypervisory and they want to use SGX? Are there ways not to overlap these two or more areas of protected memory?
So that would be, if I understand your question correctly, the hypervisor would dole out the what we call enclave page cache, the EPC. That's what we call the memory that's set aside for SGX. The hypervisor would have to dole out the ranges available to each guest VM when it starts up that guest VM.
Okay, so we can have multiple VMs using different portions of the enclave. Cool.
Absolutely.
Thanks. Good. Excellent.
So in terms of the differentiation between the different processors, different CPUs have different size enclaves. What are they using that space for? Like, what are the applications that need more enclave space versus the applications that need less?
Again, that goes back to the use case. One of the ones that the statistical modeling and AI/ML that has huge data sets, of course, is going to use as one use case that uses a lot of memory. Another one is a fully encrypted database, for example. And if you wanted to encrypt the entire database data set while it's in use, that's another way you would need a lot of memory. But as the previous question, in a cloud environment where you're running multiple VMs, you also you dole it out, and you would end up possibly using every bit of the EPC there, but it would be for different customers, different VMs running on that system. So that's another way a lot of EPC could be used as well.
And just to be clear, the limitation in size is not due to some physical aspect of the chip. It's just a differentiation of the different SKUs.
That's correct. But we do have size limitations based on the Intel, the different SKUs in the lineup. That's correct.
But is SGX available at this point across the Gen 3 Xeon portfolio, across all the SKUs, or do you need to kind of watch out for specific SKUs?
It is available across all SKUs. The differentiator is what was just mentioned, the size available per SKU. Some of them are 8 gig, some of them are larger. Yeah, cool. Much larger, up to a terabyte. Well, 512 gigabytes per socket, yes.
Is there a differentiation in terms of SGX versus the previous Xeon E CPUs and this Ice Lake generation, or is it pretty much the same technology?
It's pretty much the same technology. Any application, for example, written that ran on the previous E3 generation of SGX processors will run just fine on this generation. Yep.
So I guess to wrap up, I would just like to hear, there's a lot of different secure enclave and hardware root of trust and different approaches that different vendors are making and different claims that they're making in terms of confidential computing. What's the key, sort of the elevator pitch differentiation for the Intel Xeon third generation SGX approach versus some of these others?
Well, I think there are really two things I would say there. Number one, we are the smallest and really the smallest attack surface, TEE available in the market right now. And we're the only ones that are bare metal, meaning you only run the amount of the code and data. If you want to get that specific, you write your application. You determine what functions and what data is secured. So it's the smallest attack surface TE out there. Number two, this idea of SGX remote attestation, being able to attest not only that code running in that enclave, but it's the entire platform itself from wherever you are in the stack. If you're just an application running on some remote system, you have the ability to know all that information, to know everything is up to date, I think is the second really most compelling thing about SGX.
Is there work that Intel's doing with regulators around trying to create an SGX reference architecture that says if you use this type of approach with SGX, then you're in compliance with said regulation or compliance requirement or privacy requirement?
I don't know which regulators you're talking about, but as an example that might answer your question, we have folks who have gone out and written algorithms and written software that they have gotten FIPS certification for, as an example. Even vendors who have appliances who've gotten even to the hardware, the FIPS level 2. I forget what the
that's a little different than what I'm asking. What I'm asking about is Intel actively working with different regulatory bodies to essentially try and say, look, in cloud computing, if you want to have this regulated data set or this approach to be used, here's the reference architecture that you would use within cloud, and it kind of checks the box so that it's easier to manage, rather than a customer or enterprise trying to step back and say, okay, I got to figure out how to build this myself and comply with whatever regulation. Is Intel kind of taking that proactive step? And if so, with whom or how?
Well, there are a few of those going on. I don't know all of them. I mean, I think the one I mentioned, the program in Germany with the German healthcare regulatory commission there, is one good example that we're pushing hard to win all that business. So I'm sure there are more. I just not aware of them.
Because I would think that would smooth the rails in terms of adoption by enterprises to know that, hey, you know what? If I use this reference architecture, I have to apply to this regulation. So if I use this reference architecture with SGX, boom, I check the box. Let me move on to something else, so that they're not everybody's having to figure out how to do it themselves. They're not having to be experts themselves.